Welcome to the short presentation of our model slicing tool. We want to show you some scenarios in which our tool can be useful to improve the modeling process of a complex system. The tool is based on the Eclipse modeling framework and the model differencing tool zlift. As our running example, we will use a crisis management system. Let's have a look at the system model. The system is modeled from several viewpoints. For example, we have a large class diagram and some state machines for the behavior specification of the classes. This leads to structural dependencies between the different views. For example, a transition is triggered by an operation call. As this example shows, models of complex real-world systems can be very large. Our slicer enables developers to create consistent and editable submodels of a complex system model. Let's consider a repository that stores the complete system model. In the first step of the slicing process, the developer must select an arbitrary set of model elements, which shall be in the slice. This can be done in the remote model browser view. In this example, we select only the state machine, which specifies the behavior of the police station coordinator system class. The repository now calculates the required slice. The developer will receive the model slice as a patch. This patch will be applied to an initially empty model. The patch can be inspected in the Operation Explorer. We can see the prepared edit steps and their dependencies. Now we can simply start the patching process, which will apply the edit steps one after another. Since we are patching an empty and unmodified model, the patch can be applied successfully without any errors. Now we have a look at the created model slice. In addition to the selected elements in the remote repository browser, we will also find the class PSC system, which is the basis for the selected state machine, and the connecting called events as triggers for the state machine. We can also have a look at the corresponding diagrams. We see that the state machine diagram is fully displayable. However, only the part required by the state machine will be displayed in the class diagram. The developer might be interested in the context of the PSC system class. Therefore, we can simply go back to the remote model browser. Now we additionally select all properties of the PSC system class. Then the slicing tool creates a new incremental patch. We can apply this patch in the same way as the initial patch. The class diagram now contains the properties of the class. Also, the associated classes of PSC system were added to the extended slice. The slicing tool also supports the reduction of the current slice. Therefore, we have to deselect the unnecessary model elements in the remote model browser. For example, we can deselect the associated class police station coordinator. As before, this will produce an incremental patch which consistently deletes the deselected elements. As we can see, the class is now removed from the model and diagram. In this scenario, we modify the current slice and then reintegrate it with the original model. PSC system contains two operations named require communication. We want to keep only the overloaded operation with the additional parameter severity, so we delete the other one. Now we must update the call event of the require communication operation accordingly. The require communication operation is also used in the corresponding sequence diagram of the police station coordinator system. We extend the modified slice with the corresponding sequence diagram. This time, a problem occurred during the patch execution. The edit step create message for require communication could not be applied. A closer look at the input parameters of this edit step shows that the operation signature require communication is missing. So we reset this parameter to the overloaded require communication operation with the severity parameter. Now the last edit step could be applied. Finally, we can validate our modified slice. which shows that everything is correct. We hope you get a good impression of our slicing tool. So thank you for watching, and if you get any questions, don't hesitate to contact us.